Welcome. In this video, we're going to further discuss the derivative as a rate of change. So suppose you are driving uninterrupted by traffic lights, pedestrians, or other cars, or any similar objects down Balfour Road towards Discovery Bay. Of course, this is also assuming you could just drive down this road for hours at a time. You are maintaining a velocity of 40 miles per hour. Sketch a graph of your position, and then what is the acceleration of our car as we drive? So here I have the beginning of a graph, and let's go ahead and label our axes. Our horizontal axis is time in hours, and our vertical axis is miles traveled. Now we need to graph our position with respect to time. So after 1 hour, we will have traveled 40 miles since we're going at a constant velocity of 40 miles per hour. So that's there. Now let's go ahead and connect our origin to that dot. All right, so since we're given no other information about how long we travel or anything else, this is all I'm going to sketch here. So this makes it really clear that after 1 hour, we've gone 40 miles. It also makes it clear that our rate of change, that is delta y over delta x, where this is x and this is y, is 40 over 1 miles per hour. What is the slope of the tangent line of this position function? So I'm going to call this s of t, and this is our position function, s of t. What is the slope of this line? Is the slope changing or is the slope constant? Well, this position function makes it really clear that no matter where I sketch a tangent line, the slope of that tangent line remains unchanged. So our tangent to this curve at any point is constant. That tells me that the velocity of this curve is constant. Next, what does this tell us about the acceleration of this graph? Or excuse me, the acceleration of this vehicle. Well, think back to times when you've been driving. If you're put on cruise control and you're going at a steady 40 miles per hour on a flat surface, does your car accelerate at all? It does not. In fact, the acceleration is 0. So the slope of our tangent line is going to be constant. So if I were to sketch v of t here below, this graph would look like this. The slope of this line, this constant line, is 0 since it's a horizontal line. So the graph of the acceleration would be here. This would be a of t right along the x-axis. So the acceleration of this car is 0. I hope the content of this video was helpful.